Hi everyone, today we're talking about how to solve volume of cylinders, spheres, and cones word problems. You do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it, but don't fast forward so much that you miss out on something important. So as a review, we learned that the volume of a cylinder is the area of a circle, pi r squared, multiplied by the height, so that we can figure out the total area inside, or space inside, that cylinder by figuring out the area of a circle and multiplying by all the layers. And then we also found out that the volume of a cone is basically 1/3 the volume of a cylinder. It fills up 1/3 of the way. And then the volume of a sphere fills up 2/3 of the way. So kind of cool that a cone and sphere can fit inside a cylinder when you have the same height and width. Obviously, if you have a super tall cylinder, it's going to fit way more than that. But if all three have the same height and width, that's how they're related to each other. So that's a way that you can visually remember how their volumes formulas are related to each other. So you want to keep these volume formulas with you as you're working on these problems. Remember, the end goal is to memorize those formulas, but as you're working, you can definitely keep them on the side. So let's head over to Khan Academy and try out our first word problem. This problem says that Francisco is making an effort to drink more water and has set a goal of 2 liters per day. He wants to know the volume of the water bottle he takes to school each day. The water bottle has a dimension shown in the diagram. This sounds like something I did the other day because I wanted to know if I drank 2 of my hydro flasks at school, if I was on track to drinking the correct amount of water per day, or if I was, not on track. And I lost the the tag to my hydro flask, so I don't even know how much volume is inside. So I had to figure something like this out. So go ahead and pause the video, see if you can figure out the volume of Francisco's water bottle. All right, so first we have to figure out the shape of this. This is like a soup can or hydro flask. So that was the first type of 3D shapes that we covered. So it's going to be our basic cylinder. So we're going to write down the volume for a cylinder. We know it is area of a circle, pi r squared, multiplied by the height, so we can get all the layers. And we know r squared is basically radius times radius, so we gotta keep that in check. Let's see, it doesn't say if we can keep it as pi, so we can try just keeping it as pi. The radius is 4 centimeters, multiplied by another 4 centimeters, and multiplied by the height, which is 20 centimeters. So this would be 320 pi centimeters squared, cubed, because there's 3 of them. And if that doesn't work, then we'll have to multiply by the pi, 3.14, but it should work. There we go. So what I meant by that is another way you could write it is 320 multiplied by 3.14. You would have to do that in your calculator to get that answer, because they didn't specify what type of answer they wanted, but most would accept that answer. Okay, so remember your task is to try and solve these without looking at the volume formula sheet. But if you do have to, please, of course, use it. Okay, this one, they're being nice to you. They clearly gave you the name of the shape. A French fry stand at the fair serves their fries in paper cones. I'm sure you all have gotten that before. Get your French fries in the paper cone. The cones have a radius of 2 inches and a height of 6 inches. It is a challenge to fill the narrow cones with their long fries. They want to use new cones that have the same volume as their existing cones, but a larger radius of 4 inches. What will the height of the new cones be? So they want to have the same volume, but a larger radius. So they want to know, what does that height have to be to keep that same volume? So go ahead and pause the video and try it on your own first. All right, so we basically have two types of cones. We have the old cone, okay, and then we have a new cone. So I'm gonna first figure out the volume of the old cone first. It says that it had a radius of 2 inches and a height of 6 inches. That's for the old cone, so I'm gonna keep it on this side. Cone's volume is 1/3, so I'm basically gonna do the pi r squared h, that's the cylinder, divide by 3, because remember a cone is 1/3 of that. So the radius for the old one was 2 inches. I have to multiply it by itself again. And then the height is 6 inches. And then at the end I'm going to divide that by 3. Okay, so when I do that, in my calculator, 2 times 2 times 6 divided by 3, I should get 8, and then I still have the pi, 8 inches, 8 pi inches cubed. They're saying the new cone, they want to keep it as this volume, okay, so we're not done yet. But it has a radius of 4 inches. They don't know what the height is. So let's fill in as much information as we can. It's going to have the same volume, so same formula. Now they're telling us the volume wants to be the same, so it's got to be this. It's kind of weird. We have stuff on this side, but that's the volume that they want. They want to keep the same amount of space inside the cone. Maybe it's like a different design or something like that, but they want to keep, because like they're a business, right? They don't want to give people more fries because then they're going to lose money. And they also don't want to give people less fries because then people are going to be like, hey, what's up with this place? Like, I have less fries now. I don't like this place anymore. So they want to keep the same amount for their customers. Okay, the radius is 4 inches times 4 inches. We don't know the height, so we'll keep it at h. Divide by 3. Okay, so here's where I'm going to use a different color pen. So this is the information that we know. Same volume as the other cone, different radius, don't know the height. I need to figure out the height. I'm going to first cancel out these pi's on both sides because they're on the same side, so they're redundant. I can cancel them out. They're doing the same thing on both sides. Anything that's repeated on both sides can be canceled out. That's the only thing that can be canceled out. So now we have to start doing stuff in reverse. If this is divide by 3, if I want to get rid of it, I'm going to multiply by 3. So those cancel. So now I have 24 by itself because we already canceled both the pi's on both sides. And then we have, let's combine these two together. 4 times 4 is 16 inches squared. This is supposed to be inches cubed because that was the volume. Volume's always inches cubed times the height. So what else can we get rid of? We can get rid of the 16 and the inches squared. Cancel, cancel. By dividing. So we're going to do that on both sides. Okay. 24 divided by 16 is 1.5. Okay. So, and then I have 3 inches on top here. And then I have 2 inches on the bottom here. 1 inch cancels out with the other inch. This inch cancels out with the other inch. So I only have 1 inches left. And then on this side I have height. So the height equals 1.5 inches. If you don't believe me, put it back in here, and then we can see if multiplying and dividing all these gets us back to 8. So in my calculator, let's try it. So we're going to have, let's see, 4 times 4 times 1.5, our height, divided by 3 should get us back to 8. Yes, so that answer is correct. Okay, so the answer is 8. Oh, sorry, not 8, 1.5. They're looking for, okay, I put in the wrong number. 1.5 for inch, or for the height. Duh. All right, so again, we put in the information that we needed. We canceled out the pi's because those two are the same on both sides. Then we are doing the opposites. So the divide by 3 was on this side, so we're going to need to multiply by 3 on both sides. That's how we got the 24. And then we divided by the 16 inches squared, which was over here. 24 divided by 16 was 1.5. And then we got rid of both these inches here and 2 inches above as well. So we were just left with inches. So we got 1.5 inches. That's as difficult as the problems we'll really get, is this problem. But other than that, you have to try and remember your formulas and then use the information given to figure out the answer. Let me know if you have any questions as you work on any of these, and I'll see you in class.